Assalamu alaikum. Today we're gonna talk about the chain rule differentiation technique. So several of we have been using the long method of differentiating such functions that involves the chain rule differentiation technique. Today I wanna show you the simplest way to apply the chain rule technique. The simplest way to do with the chain rule technique. Now, let's look our equation D there. So suppose the function of y is given by what? X squared plus 1 raised to power 3. So wherever you see such a function, when a function is raised to power, then the best technique to apply there is the chain rule technique. So this chain rule technique is normally applied to the raised function, the trigonometric function as shown below. So when given a function sine squared of x equals to that sine squared of x, it is mathematically correct to rewrite it as a sine of x squared. This is mathematically correct. Also applies to cos and tan and any trigonometric function like sec and cot and more of them. So I wanna show you the long procedure that most of we use to evaluate such functions using the chain rule technique. So, and I'll further show you the simplest way of applying the chain rule technique. Now, let's start. Given a function of y equals to x squared plus 1 raised to power, any power, then there's no any other technique that you can apply there. The simplest one, you have to just use the chain rule technique. Now, let's apply it here. Chain rule techniques, you just assume you let the inner function. Can't you see that function is powered? Just substitute that inner function with a variable. So you just let the inner function, which is x squared plus 1, be u. I think there we are understanding what we have done. Just substitute the inner function with a variable like u. Therefore, our new function of y, it will be y now equals to u raised to power 3. Now, for you to apply the chain rule technique, leave alone with this function. Since you have taken what you needed, then leave alone in that function. Now, let's come and deal with the two functions, function 1 and function 2. Let's differentiate this function of u now in terms of x. So given u equals to x squared plus 1, therefore du in terms of x, which is du dx, it will be differentiate x squared, which is 2x. Then since 1 is a constant, it becomes 0. So we have this first derivative for the first function. Let's find the derivative of the second function. So given y now, this is function of y here is u cubed. Then the first derivative of this one, dy, in terms of u. Du, it will be just 3 multiplied by coefficient of u, which is 3, then u, 3 minus 1, which is 2. Therefore, we are done with differentiation of the two functions. Now, let's see how will we now get the derivative of that function. Remember, the derivative of that function was to be dy over dx. We were to differentiate this function over in terms of x. So we need dy dx. Why do we need dy dx? The question was not asking about du. The u, you are the one who you brought it. Now, the question needs dy dx. How can we obtain dy dx from the two functions? We can see the first function here and the second function here. Now, let's see how we can obtain dy dx. Suppose the first function is du dx, and the second function is dy du. Just write them like that. Now, ask yourself, what should you do so as you come up with dy dx from the two functions as you see them below? What you can, for me, I can see there, when we multiply the two functions, therefore du and du cancels out and we remain with dy dx. So we know that getting dy dx is just multiplying the results of the two functions. Therefore dy dx, it will be just 2x, the function of dy du dx, multiply the function of dy du. Then let's multiply it, which is 2x, then multiply by 3u squared, as shown here. So the product of the two functions is the derivative of this function. Therefore, dy dx, it will be just 6. Just first, before opening this bracket, let's substitute the value of u. The value of u, we currently substituted u to be x squared plus 1. Therefore, dy dx, it will be 2x into 3 multiplied by u, where u equals to x squared plus 1. X squared, u equals x squared plus 1. Then, but u what? U is squared. So square u. There. Therefore, dy dx is just 2 multiplied by 3 multiplied by x, which is just 6x into x squared plus 1 squared. Hence, this is the derivative of that function in terms of x. I think we are all together there. Now, let me show you the simplest way to apply chain rule. Suppose we have the same function, y equals to x squared plus 1 cubed. Before showing you the simplest method to differentiate such a function using chain rule, let's go back to this, our answer. We can see that we have a 6x multiplied by x squared plus 1 squared. How did this arrive? Let's go back to our function. It seems that this person took the derivative of the outer function. Can't you see that there's the larger function? The larger function, you can say that is the function powered. This we can call it the larger function. And there's the smaller function in there. Can you see it? There's a smaller function, and this one is the wall function. The inner function and the outer, let's use that term, inner and outer function. Now, let's say we are differentiating the outer function without considering the inner function. When you differentiate, just use the power rule now. So the coefficient of the outer function is 1. Therefore, just multiply by 3, then minus 1. When you multiply by 3, this it will be 3, then minus 1, it will be squared. Let's come back to this, our answer. Let's come back here. Can't you see that we have multiplied by 3, then minus 1? Can't you see that we have differentiated the larger function? Now, let's see the differentiation of the inner function. What is the derivative of the inner function? This is a constant, it will become 0. But 2x squared, it will be 2x. The derivative of x squared is 2x. Let's come back to our derivative. The derivative, can't you see 2x is here? Therefore, we can conclude that the easiest method of using chain rule, you just take the derivative of the outer function multiplied by the derivative of inner function, and it is done. Now let's apply it here. Therefore, dy dx without substituting, you can just simply do it like this. Now the coefficient of the outer function is 1. Therefore, this differentiation, it will be just you just ignore the inner function first. Therefore, differentiate the outer function. It will be 3 multiplied by 1, which is 3 into, just assume that you are not seeing the inner function. Therefore, it will be 3 minus 1, which is squared. Then multiplied by the derivative of inner function. The derivative of inner function equals to what? 2x plus 0, which is 2x. Therefore, just look this method. This method is the same method, but it's the simplest way of applying the chain rule technique. Therefore, can't you see this one is the same as this one? Therefore, 2x times 6 times 3, it will give us 6x into x squared plus 1 squared. Hence, it is the answer. But for you to avoid this working, just apply it as shown, and it is simple and easy. Now, let's apply it this simplest way to differentiate such functions of y, like the trigonometric functions. Suppose we have the function a, which is the function of y is given by sine squared of x. But you can see sine of squared of x mathematically is the same as writing it sine of x squared. But we said that wherever you see a function of x being squared, function squared, then the easiest technique, or the technique that is suitable for differentiating such a function, is the chain rule technique. Now, let's apply the simplest chain rule technique. The simplest chain rule technique, it will be just the coefficient of the outer function is 1. Therefore, just use power rule technique to differentiate the outer function. Power rule technique says that we just multiply by the coefficient, which it will be just, so dy over dx, it will be just the derivative of the outer function, which is 2 into, ignore the inner function first, then 2 minus 1, it will be power 1, multiplied by the derivative of inner function. The derivative of sine, mathematically, it's just cos x. So, therefore, finally, we can write this one as dy dx is just equal to what? Sine x 2 sine x cos x. Hence, differentiate. Can't you see this is simple than using the substitution one? The substitution one needs a lot of working that may result to errors. Maybe now I just suggest for we to just apply it simpler as we have been doing here. So for more differentiations and other mathematics concepts, just subscribe. So if you feel like that this is helpful to you and it has helped you, so don't be selfish, because also I want to benefit from it. If you benefited from it, also I want to benefit from it. So just subscribe. So don't be selfish. If it has helped you, also help me by subscribing, liking, and you will be updated from my channel when any video I upload any video there. So thank you very much for watching the video.